Hi, Assalamualaikum. Today me and my friend will present about our assignment, which is a conduction graphical analysis on heat transfer, which is heat sink. So, my group member is DOLORYEN DANELLO TEGONG bin Thomas, KHAIRIL FITRI bin Muhammad AMIN, MADIHAH FARHANA binti Muhammad FIKRI, and myself, which is NURYN binti Muhammad YATIM. So, introduction for our assignment. When we talk about heat sink, we need to know what is a mean and what is actually a heat sink. So, heat sink is a component that helps to transfer heat away from a hot device. It's achieved this by increasing the device working surface area and the amount of low temperature fluid that flow through it. Fourier's law of heat govern the heat sink operation. Heat move from high temperature area to lower temperature area whenever temperature differential occur in a body. Radiation, convection, and conduction are the three different methods in which heat can be transmitted. So objective for our assignment is first to create two different fin surface according to our own creativity using a suitable software. Second, to perform heat transfer simulation process using suitable software on a fin surface. And lastly is to prove the effectiveness of the heat sink simulation. That's all from me, and I will pass the next slide to the next presenter. Thank you.
Hello everyone, my name is DOLORYEN bin Thomas from 2BMMH section 1, and my task today is gonna talk about the design for our assignment. Okay, before I talk about the design, let me talk about the concept of the heat sink first. So assume these two pillars are the fin of the heat sink. As the two fins got hot, the air circulates over here will go up. This is due to buoyancy law, and since the base of the heatsink is heated or hot, the temperature increases, the temperature will go up following with the airflow. Okay, we have two designs. One design is a pin fin type, and the other design is more to extrude straight fin type. Okay, this is heatsink 1, our first design, and our base for the dimension of the base is 40 mm times 40. The weight is 40 and the length is also 40. And you can see this is the pin fin design, and this is the dimension of the interior of the pin fin design. And next I'm gonna talk about the extrude straight fin design. Okay, as you can see, this is the extrude straight fin design. The base is the same dimension, 14 weight and 20 in length, and the height of the design is 19.5 mm, and you can see the distance between one fin to another is 1 mm. And that is all from me. Next, I will let the next speaker to talk about the result and how to get the result from the heatsink in SolidWorks. Okay, thank you for listening and have a good day.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is FITRI bin Muhammad Amin and my matric number is B0920101147. Okay, I will explain for the result for the heatsink. Okay, as we know, we have two design of heatsink. Okay, for the result heatsink 1, the mass for the heatsink is 0.028 kg and for the volume is 10696 millimeter cube. Okay, look at the result at the cold side, which is at the blue side. The temperature is 76.6 degrees Celsius. Okay, this number represent the degree Celsius, not Kelvin. If we want the result in Kelvin, just add 273 and we get the Kelvin. Okay, for the cold side, the Kelvin is 349.6 Kelvin. Okay, at the hot side, which is at the red part, at the bottom of the heatsink, the temperature is 97.3 degrees Celsius. And if we want the result in Kelvin, at 273, we get 370.3 Kelvin. Okay, and for the heatsink 2, the mass for the heatsink 2 is 0.0132 kg and the volume is 13420 millimeter cube. Okay, the temperature is same as the heatsink 1, which is at the cold side, is 76.6 degrees Celsius, and at the hot side is 97.3 degrees Celsius. Okay, as the heatsink is far from the heat source, the heatsink get colder. So we can see from the red, it turn into yellow, green, and then blue. Alright, thank you.
Hi, Assalamualaikum and good evening. Today I'm going to present the discussion and conclusion for this assignment. My name is MADIHAH FARHANA binti Muhammad FIKRI, number matric B0920101195. Just now, KHAIRIL just present the result of heatsink, also the video design that was drawn. Okay, so based on the previous slide and videos, both of the heatsink are made from the same material, which is alloy, aluminium alloy. So you can see that the convection occurs between the cold side of the fin surface and the surrounding air. Okay, the ratio of heat transmission with a fin versus the heat transfer without a fin is used to determine a fin's effectiveness. So in the absence of a fin, heat is transferred by demonstrating the convection performance from the fin's area. So the efficiency of a fin with a fine length also rises with the length itself. Basically, a heatsink is made to have such much bigger surface area as possible in contact with the cooling medium that surrounds it, such as air. So the performance of a heatsink is influenced by air velocity, material selection, protrusion design, and surface treatment. Basically, heatsinks are crucial in circuit design because they provide an effective conduit for heat that can be transported from electrical device to ambient temperature. And the last one is the conclusion. So we managed to create two different fin surface using a suitable software, which is we're using SolidWorks to draw the design, and also managed to improve which material shows the best heat conductor for the heatsink. And we also discovered that the heatsink with a bigger surface area allows for more efficient heat performance dissipation through the fins. And we also learned that the number of fins in a heatsink had an effect on heat dissipation, as was demonstrated in both design in the video previously. So by using a different material or a better design, the heatsink performance also can be improved. So that's all from us now. Thank you.